Hi students, it's Mrs. Gifford here, and today I am going to talk to you about lesson 10-7, all about similar triangles. After this lesson, students will be able to determine if two figures are similar and find the values of unknown values of similar figures. So what are similar triangles? They do not necessarily have the same shape. They have the same shape, but they are not necessarily the same size. So if we take a look at this key concept, it says if two triangles are similar, then the measures of their corresponding angles are equal. So if we look down here at this diagram, we would say that angle B and angle E are corresponding angles because they're in the same spot on each of their triangles. And if we look closely, they're both 60 degrees. Okay, angle C and angle F are corresponding angles. They're both 30 degrees. And then angle A and angle D are corresponding angles, and we see that they're both 90 degrees. So because all three angles in both triangles are the same, we see that we can say that they are similar triangles. In the same regards, the measures of corresponding sides are also proportional. So if we take a look at side BC right here, which has a length of 6, and the side EF, those are corresponding parts, it has a length of 12. And if we set up a ratio or a proportion of side BC over EF, it's 6 over 12, which simplifies to 1/2. And then if we look at side AC, it corresponds with side DF. And we set 3 square root of 3 over 6 square root of 3. And we simplify. The square root of 3's cancel each other out. And 3/6, as we know, becomes 1/2. And then side AB and side DE also correspond. And so we can do the same thing and set up a fraction. That's 3 and 6, which also simplifies to 1/2. So because all of these proportions ended up simplifying to 1/2, there's another case in point as to why these two triangles are similar. So let's take a look at some examples. Example number 1 says determine whether triangle ABC with the measure of angle A at 68 degrees and B and C are the same. We're going to see if it's similar to triangle DEF, and DEF has angles E and F that are 54 degrees. So the first thing I'm just going to do real quick is just sketch two triangles, and this one's going to be triangle ABC. And I know that the measure of angle A is 68 degrees, and I know that B and C are the same, but I don't know what their angles are, so I'm just going to call them X. And then I have triangle DEF, and I know that E and F are 54 degrees. I don't know angle D. Now here's the thing, as we just got done talking about, these two triangles are going to be similar if where we labeled X is going to be the same as each of those two angles because they're corresponding. So the first thing that we want to do is figure out the measure of those angles. So I'm going to create an equation for this, and I know that the angles of all triangles add up to 180 degrees. So I'm going to write X plus 68 equals 180 degrees. Those are the three angles of triangle ABC. Combine my terms, I get 2x plus 68 equals 180. Now I want to solve for x, so I'm going to subtract 68 from both sides, and I get 2x equals 112. And if I divide by 2, I get x equals 56. So what we've just figured out that angle X, or angle B here, is 56 degrees, and angle C is also 56 degrees. And we just got done talking about the fact that in order for them to be similar, the angle measures need to be the same. Well, these are 56 degrees, and angle E and F are 54 degrees, so these two triangles are not similar. because the angles, this is my angle symbol, the angles are not the same. Okay, so that's the first thing that we want to take a look at, is see if those angles are the same. So now let's take a look at example 2 where we know the side lengths and we have to figure out if these two are similar. Same thing, we have two triangles. And again, I'm going to draw a picture to represent our triangles. So we have triangle ABC. And I know this side length is 6, BC is 16, and AC is 20. And then I've got this other triangle, J, K, and L. And I know JK is 3, KL is 8, and JL is 9. In order for these to be similar, the ratios of corresponding sides needs to be the same as well. So I'm going to set up a ratio of AB over JK, and I do that because those are corresponding parts. The length of AB is 6, JK is 3, so this simplifies to 2. I'm going to write a proportion of BC compared to KL. BC's length is 16. KL's length is 8, and 16 divided by 8 is 2. So we're good so far. We've figured out the first two pairs of sides come up to the same ratio. And then the last one, we're going to check to see what side length AC proportional, to see what the ratio over JL becomes. AC is 20, JL is 9. Well, we know this does not equal 2. It's actually going to be a little bit more than 2, 2.22, I believe. But I know that 18 divided by 9 is 2. And because 20 is bigger than 18, I know that this is not going to equal 2. So what do we know about this, or what can we say about these two triangles? These two triangles are not similar. Because the corresponding sides are not all in proportion. Okay, so the ratios of those sides has to equal exactly the same thing in order to be considered similar. Alright, so let's take a look at the next one. So example 3, now that we've talked about the fact that if they are similar, their angles need to be the same, and also their corresponding sides have to have the same proportion. In this case, we know these two triangles are similar, and now we have to find this missing side length of x. Now if you look closely in this particular drawing, there are two triangles. What I'm going to do is take these two triangles and separate them out. So I've got the big triangle. This length is x. The bottom length is 11. And I've got this smaller triangle where I have this is 5, this is 7. Okay, and we know that these are right angles. And because this little triangle is nestled right inside here, we know this little angle is the same. And if two of the angles are the same, then we know that this third angle is the same as well. Alright, because of this, and we know that these two triangles are similar, because of this and we know that these two triangles are similar, what we're going to do is set up ratios. Sorry about that, I'm going to move this so we can see it a little bit better. We're going to set up these ratios, or these proportions that we just talked about with the last example, and look to see find what this missing value is. Okay, so from here I'm going to take x and set it up as a ratio over 5 because those are two corresponding parts, and then I'm going to take 11 and put it over 7 because they are also corresponding parts. Now notice the numerator in each of them is from the big triangle. You want to stay consistent, and the denominator is from the little triangle. Again, staying consistent. We could have flipped it around and put 5 over x equals 7 over 11 and solved it also. Okay, once you get here, we're going to take these numbers and we're actually going to do cross products, which means multiply on the diagonals. So we get x times 7 and we're going to set it equal to 5 times 11. So we get 7x equals 55. And then we just have to do one step to solve for x, and that's divide by 7. So in this case, we get that x equals 7.86. And I rounded that answer to the nearest hundredth. So because these two triangles are similar, and we have all of those sides, we found out that the length of x is 7.86. Now, let's take a look at our last example for this lesson, and it says the directions for pitching a tent include a scale drawing in which 1 inch represents 4.5 feet, and in the drawing the tent is 1 3/4 inches tall, and we have to figure out how tall should this actual tent be in real life. So just like with the problem before, we're going to set up two ratios, and in this case I'm going to set up my ratios with the information about the drawing as my numerator number and the information for the actual tent as my denominator. So let's look back at the problem and figure out what pieces of information we can fill in. So it says in here that the directions for pitching a tent include a scale drawing in which 1 inch represents 4.5 feet. So I have 1 inch in the drawing, and I have 4.5 feet in actuality. Then it tells me in the drawing, oops, there's a typo there. It tells me in the drawing that the tent is 1 3/4 inches tall, and I'm going to change that to a decimal. 1 3/4 is the same as, oops, not 7.5, 1.75. And the question is, how tall should the actual tent be? And so we are looking for the height of the tent, so I'm going to pick the letter H to represent that. From here we're going to solve it. So just like the problem before, I'm going to do cross products. So I have 1 times H equals 4.5 times 1.75, and 1 times H is just H. And 4.5 times 1.75 is 7.875. So what did we just figure out? We figured out that the tent should be 7.875 feet tall when it's completely assembled. So there you have it, folks. Now you know all about similar triangles and how to find missing measures of the different sides in similar triangles.